Alright, so in this video, we will try to understand regression analysis. If you want to understand the relationship between two variables, then we can do regression analysis. So it is a statistical technique used to model the relationship between one or more independent variables. So in this case, we have a data set where we have months. For each month, we have the rainfall in millimeters and the quantity sold for that particular company, right? So this is my dependent variable. So quantity sold is dependent on the rainfall. So this is my input variable, rainfall, right? So there can be multiple variables, input variables. So if we have single input variable, we will do a linear regression, and that is a single variable linear regression, as we say. And if we have more than one input variable, that will be multi-linear regression, right? So we will try to understand both the concepts, and we will try to create the graph and do some kind of analysis. So first of all, now that we have our input variable and the output variable, that is quantity sold, if we have to analyze, let's say we have the data until March 2025 and we want to predict for April 25. For example, if we have a forecast of rainfall, let's say 60 millimeters for April, what will be the quantity sold? Similarly, in the May month, uh, using the weather forecasting website, I got to know for May the rainfall in millimeter is 62 for month of May. Then what is the quantity sold? So how can you do that? So first of all, we will try to create a relationship, and that is a linear regression that we will start with. So if you see here, type of regression analysis, first is linear regression, then multiple linear regression, then logistic, and there are so many others. So if we go with the basic, that is linear regression, it models the relationship between dependent variable and one or more independent variables using straight line equation. So this is like similar to y is equal to mx plus c, and where my m is slope and c is intercept, right? So here as well, so this is beta naught plus beta 1x plus some error, right? So this is how the equation looks like, and we will try to create this equation using this. All right, so now in order to create this, we will use a data analysis tool in Excel. So if you go on data, we have this option of data analysis. If you're unable to find this data analysis, just click on the file. I assume you're working on Windows, then click on file, then click on options, then click on add-ins, and in the Excel add-ins you should see data analysis, and you can add that in your bar. Alright, so once you have this, click on data analysis, and I want to do regression. There are so many other options. You can do ANOVA, you can do correlation, you can do histogram. We will do all these things in upcoming videos, but in this video I'll explain you regression. So I'll click on regression, click on OK, and the input Y range. So input Y range, so my output is the quantity sold, so I'll select this, and the X range is my rainfall. So once I have selected this, just remember that I have selected the label as well, so I'll have to select the labels from here, and I can keep this as it is, so it should be added in the new tab in the same worksheet. Click on OK. That's fine. So now this is what you will get, right? So this is my regression statistics, then this is the ANOVA analysis, and this is the equation. So intercept is there, then the rainfall coefficient is also there. But before this, if I go back here, let me create a simple plot. So what I'll do is I'll just select this, click on insert, click on recommended chart, and this is fine with what we want. This is a scatter plot, right? So you can see here, this is a kind of a linear regression. So you can see it is negatively related. So on y-axis I have the quantity sold, on x-axis I have the rainfall, and you can see there is a pattern. So it's not like random. So one dot is here, then here, then here. So it's not like random, it's decreasing. The quantity is decreasing with the rainfall increase, right? You can see here. So there is a negative relation between these two variables. So now if you select any particular dot and right click, I can click on the trend line, where is my trend line? Add trend line. So you can see here the trend line has been created, and if you think this is exponential, just select exponential. There will be some kind of curve over here, but I'll keep linear as of now. This looks good. And now if you want to display an equation over here as well, so you can select this checkbox, display equation on chart, and this is the equation that you will get, right? You can make it bold, expand it a bit to make it visible. So now that you have this equation, so if you compare this with y is equal to mx plus c, here my m is equal to minus 4.0336 and c is equal to 878.13, right? So we have m and c, and for here my x is 60, rainfall is 60, right? So is equal to m is my minus 4.0336 multiplied by 60 plus my intercept is 878.13. So according to this, the quantity sold would be somewhere around 636, right? And now in the month of May, again minus 4.0336 multiplied by 62 plus the intercept is 878.13. So this is how you can see in the month of May 62, and this is how it is. So I can make it dynamic and select this. And now if you think, instead of 62, the rainfall in the month of May was somewhere around 35. So you can change it and you will see the values changing on that basis, right? So now you have understood, using the particular scatter plot, how to get the equation, and through the equation how to get the final outcome, right? So this is one reason. But now that you got the solution, is it correct? So when we say in the month of April, when the rainfall is 60 millimeter, the quantity you can sell is somewhere around 636. So if this is correct, then that is great, because you can do all kind of projections for supply chain, for all the procurement of raw material, so as to capture on the basis of what is needed. But if it is incorrect, then everything will go on toss, right? So it is very important for us to be confident that this value that we have calculated is correct, or at least to some extent, right? So in order to get that confidence, we do that regression analysis. So what we did, using selecting everything, then we went to data, clicked on data analysis, clicked on regression, and then we got this, right? So this is a very important concept. So regression statistics. So you can see there are total 5 stats: multiple R square, adjusted R square, standard error, observations. So first of all, very important aspect in this is R square. R square is 0.915. That means 91.5% of the variables are being understood or explained by the input variable, that is the rainfall in millimeters, right? Adjusted R square is used when you have multiple inputs. So in this case, we don't need this. Standard error is the average distance that we have for each and every value from the regression line. So if we go back to this line, so if you see this dot, for example, if we do the perpendicular line from this dot to this regression line, so this is my standard error for this dot. Similarly for this dot, it will be standard error like this. So if we do all the cumulative sum of all these standard errors, that is my total standard error, 37.75. It should be somewhere near 0, of course. If it is near 0, that means the accuracy is very high. If it is massive, it is like thousands, or it depends on the values as well, like what kind of values we are dealing here, right? So if it is quite absurd, it's too high on the basis of what we have, then we need to revisit, and it is not that great. Observations equal to 16 is simple. If we sum these rows, these should be 16, right? So we are taking 16 observations over here. So now let's go to explanation here. So if you see multiple R, it is the correlation coefficient measuring the strength of the relationship between the dependent and independent variables. So here the dependent variable is my quantity sold, independent variable is the rainfall in millimeter. So it will give you the strength of relationship. Here we are getting 95.65%. So 95.65%. So the strength is 95%. So this is very high. So that means it is a very good news. Now if we go to the second part, that is R squared. This is the proportion of variance in the dependent variable explained by independent variables. So if there is any variation, how much is explained by the independent variable, how much it is explained by the rainfall in this example, that is somewhere around 91%, 0.5%. Yeah. So now a third part is adjusted R square. So this is a modified version, as I explained, if we have multiple inputs. So in that case we would need this. So I'll explain you in a multiple linear regression. Standard error, the average distance that is observed values fall from the regression line, as explained. And observations is the total number of data points. Alright, so now we have understood the regression statistics. So this is totally fine. And when we are saying this is important, if we go home, let me highlight this. So this is 91.5% explained by rainfall. Now coming to ANOVA. So there are some of the terms like DF, SS, MS, F, significance F, regression residual. What are these things? So I won't go in depth, but I'll explain you in a nutshell so that you understand what's happening. Very important value here is this one. So if you see significance F, it is 6.9 into e raised to power minus 9, which is way less than 0.05. So this is what is actually needed. If we say this p value is less than 0.05, that means the values that we are getting can be used in our system. So if I go back to explanation, so you can see this is the significance of model that we were talking about, which is 6.9 into e raised to power minus 9. So if we see here, if p is less than 0.05, the model is statistically significant and we can use those values. Now if you go here in regression, this is sum of squares. This is sum of squares for regression. It measures the variation explained by the model. Then if we talk about the sum of squares for error, it measures the variation unexplained by the model. So if we go here, this is the sum of all the variation unexplained by the model, 19,960. And the F statistics, which is here, which is MSR divided by MSE, it tests whether overall regression model is significant or not. So here we are getting 150, right? So you can see over here, and in conclusion, so there are two things: regression statistics and ANOVA analysis of variation, right? So regression statistics provide the summary for how well the model explains the data. ANOVA table helps in understanding the significance of the regression model by the breakdown, the variance. All right. So here it is very important to understand another part over here. So we have intercept. So if you see here, 878.12 is same as the intercept that we got in the equation. So if I go back to SLR dataset, if you see here, my intercept is 878.13 and we are getting 878.12. So minute change. And this rainfall thing as well, slope, you can see is minus 4.033. Here minus 4.0336, and here it is 4.0335. So again minute change. So here my equation will be equal to y is equal to m. So it will be equal to, this is equal to m into, let's say, x. Let me just create here my x value, my y value. So y here is equal to m multiplied by x plus my intercept, right? So these value will remain constant, So I can make it fixed. All right, so now if I say rainfall is somewhere around 50 millimeters, so this is in, so if it is 50, then I'm saying quantity sold, the quantity is 676. If I say it is 100 millimeter, then if I copy this, so I'm saying quantity will be way less, which is 474. So this is what we saw, right? If we increase the rainfall in millimeter, then the quantity sold would be less. There is a negative relationship between these two variables, right? So we could see from both of them, like from the equation as well as from the regression, and we can see r square is highly, like it's greater than 90. So it's amazing, 91.5% is explained, and significance level is way less than 0.05. So it is statistically significant. The model is statistically significant, so we can use this, right? So this is fine. So let me just write this SLR regression stats. All right, so now we have understood if we have single variable, how we can calculate this. Now if there are multiple variables, so I can go back here. So this is my new data set. So this column, rainfall column, and the quantity sold is totally same. I just added one more variable, input variable, that is temperature in degrees Celsius, right? So now we have to see how two variables instead of one variable impacts the quantity sold, right? So first of all, we will go again to data and click on data analysis, and we have to click on regression, then click on OK. So once you click on OK, my input, so this is output, so output range will remain the same, quantity sold. So I'll select this, and in input X range I will have two columns this time, rainfall and temperature. And just observe that I have selected the labels as well, so I'll tick the label as well, and I want to keep this in new tab in the same worksheet. So I'll click this and click on OK. Now I have created this. So this is multiple linear regression stats. All right, so if I expand this, so if you see here, adjusted r square is important here because we are using multiple variables. So this is 91.4%, and here r square is 92.6%. So when we say r square initially was 91.5%, now we can see it is 92.6. So it has increased by somewhere around 1%, and this is a better news. So what we say is if the r square improves when we add new variables, so one option is we can say directly that, hey, by adding new variable we are increasing r square, so that is better. So we have to use more variables so as to give more understanding on the model. So this is able to explain 92.6% of variation in the model. It's still not 100% because that's highly unlikely. You can't get 100% accuracy, 100% confidence using multiple variables. For example, if you're using 10 input variables instead of one or two, still you won't be able to get 100%. So that's where we have to understand how many input variables we can utilize so as to achieve a certain percentage. So when we say 90%, 95%, it is good enough if we are using 2 or 3 input variables. But if we are using 10 input variables and we are able to increase just 1%, then I think it is okay to avoid those input variables so as to keep our model simple and getting almost good accuracy. Right, so now that we have got 92.6% r square and adjusted r square is 91.4, you can see standard error now is 36.5. Initially it was 37.75. So it is better definitely. Right, and you can see the most important part, significance F, is way less than 0.05. So our model is statistically significant. Right, and now here my equation, so if you go back to what I was explaining in multilinear multiple linear regression, y is equal to m1 x1 plus m2 x2 plus multiple variables plus c. So this is how the equation looks like now, right? So there will be multiple slopes and one intercept. So if I go here, so the equation will become, so x is in this x1 x2 and then y. So y is equal to mx. So first slope is my temperature, or we can say rainfall into x1 plus second variable into x2 plus intercept. So this is my new equation and I can fix these cells. All right, so this is my rainfall in millimeters and this is my temperature in degrees Celsius and this is the quantity. Now if I say rainfall is 100 millimeters and temperature is somewhere around 20 degree, so quantity sold would be 516 in this case. And now if I say rainfall is somewhere around 75 millimeters and temperature is 14 degrees Celsius, I would say 538 quantity should be sold. So when we have multiple variables and we can easily fetch these data from weather forecasting websites. So when we have for a particular month, let's say the next month is April 2025 and we say the rainfall is 75 and temperature is 14 degree, so how many quantity we can expect that will be sold will be equal to 538.29. so of course it can never be exact, so you might see 500, you might see 538 if you're lucky, or you can see 600, but this is always as a predictable values, so it's not always true and mostly it is not true. So this is how you can do regression in Excel. And as we went there, so there were two things: linear and multiple linear regression. And apart from this, you can see there are so many regression analysis concepts. One is logistics. It is used for binary classification, for example, yes or no, if outcome is either 0 or 1, so all those things. So we won't be able to study this in this particular video. So all we did was linear regression and then multiple linear regression. So here you can see example as well. So if you want to predict house prices based on square footage only, so only one input variable is there, so how can you predict house prices? That is linear regression. Similarly, if you want to predict sales based on advertising spend, location and product category, so there are multiple input variables, or you can say multiple independent variables to capture the dependent variable, so that is multiple linear regression. So this is what we did now. And if we go to the concept over here, so you can see this is my formula, and y is the predicted value of dependent variable, beta naught is the first it is the intercept, so y-intercept value of y when all other parameters are set to 0. Beta 1 x1 is the regression coefficient, beta 1 of the first independent variable x1, right? Similarly, you can see beta 2 x2 and so on and so forth. And the one last thing which I missed explaining, so if we go here in the SLR summary, so as you can see the rainfall coefficient was minus 4.03. So you can see rainfall coefficient is minus 4.033 as a coefficient. So what is this? So this is for every 1 millimeter increase in rainfall. So every 1 millimeter increase in rainfall, sale decreases by 4.03 units. Similarly, intercept, this means that when rainfall is 0, so rainfall is 0, when there is no rainfall, the expected sale is 878. Right, so in dry season when there is no rainfall, we expect 878 units to be sold. P-value, as we explained, since this is much smaller than 0.05, rainfall has a significant impact on the sales. 95% confidence interval. So the true impact of rainfall on sales is between minus 4.74 and minus 3.33. If we go back to our data, so you can see rainfall here, lower 95%, upper 95%, these two values, if you see here, so we are confident that rainfall between these values will give me these units. So 95% confidence we have while predicting the values. So we can do some other confidence interval as well, 90%, 85% depending on our interest, but 95% is generally used for calculation, and it is generic for all across. So yeah, so this is how you can do regression in Excel. So basically, in a nutshell, if I go back to the basic, you have two variables. One is input variable, one is output variable. What is the relationship between these two variables? You will do regression. In regression, we have linear, we have multiple linear regression. So linear is just one input or one independent variable. Multiple regression model means we have multiple independent variables through which we are calculating the dependent variable, right? So this is it in this particular video. In the next videos, we'll talk about histograms and various other data analysis concepts in Excel. Thanks a lot for watching.